Okay, let's start. So, a little bit of background of myself first. My name is San Lu, and I'm a software engineer from Google. And my GitHub handle is KRZYZACY if you want to find me on GitHub. And my co-speaker Jessie is also from Google, and GitHub handle is Jessie ZCC. And for this cover page, it's actually took by the lead of our SIG testing from Denmark, Copenhagen. It's actually from the last KubeCon, and this dog is called This Is Fine Dog, and it's our SIG mascot. The spirit is like, no matter maybe like Kubernetes testing for is break it down, or maybe GitHub is breakdown, we fix it tomorrow. It's always the way to. All right. A little bit of basic information. Testing currently has 4 chairs: Aaron, Eric, Steve, and Timothy. And you can find our SIG chart on the following link. And we have a weekly community meeting at Tuesday 1 p.m. Pacific time. Before we actually start, so how many people here has ever made a contribution to Kubernetes? Great. And how many people have your own like project, maybe on GitHub or on other Git platforms? Cool. So the main takeaway is here. If you are a Kubernetes contributor, hopefully this talk will make you more familiar with how the testing infra layer of Kubernetes work and help you understand what's happening actually behind your PR. And if you are maintaining your own project, it's also a very good opportunity to see how the Kubernetes testing infra layer can help to fit in your own project. So the agenda today, I'm going to talk you through Prow and our GitHub automation, basically how we automate everything for your Kubernetes pull request. And I'm also going to introduce all the other sub-projects we are maintaining currently under SIG testing. And next, Jessie will give you a case study for Knative, which is another open source project. And we'll leave some time for Q&A. So first slide is, I probably should give everyone a little bit of history of the Kubernetes test infra layer. If you have ever contributed to Kubernetes, let's say 2 years ago, you might remember that Kubernetes test infra was running on top of Jenkins. We have a gigantic Jenkins cluster with like over 100 nodes and running all kind of Kubernetes end-to-end tests. And we have configured various of Jenkins GitHub plugins to trying to make things automated. And later on, we figure out, we running tests on VM. We probably should containerize them. So we containerized all the tests. So it's like actually inside the Jenkins VM, we do Docker run, blah, blah, blah. And then our test infra team is actually facing various issues with Jenkins, like leaking resources. And whenever we need to upgrade Jenkins, we hit like upgrade issue. We need to tear down the cluster and reboot out Jenkins nodes, which can give a lot of downtime for the Kubernetes test infra. So we are running containers, right? We are maintaining this project called Kubernetes. So why not just use Kubernetes as our, build our test infra on top of Kubernetes as a Kubernetes native app. So obviously we abandoned Jenkins and we started this project called Prow. And we can schedule our test containers on top of Kubernetes rather than on Jenkins VM. At this point, you might still have some confusion. I've mentioned the word Prow multiple times. So Prow is actually the name of our a application that runs the Kubernetes test infra on. Where can you find Prow? There's various places. For example, when you open a pull request against Kubernetes, you will see there's this CI robot comment say, hey, thanks for your PR. By the way, your PR is not approved yet, and we suggest some reviewer for you in order to get your PR merged. And on the left side, you can see the robot also add a lot of GitHub labels under your PR. The robot will also kick off a list of pre-submit jobs to ensure your pull request is okay to merge. And your reviewer might just come in and say /LGTM and thank you for your pull request. The robot will add the LGTM label on under your PR, and once all of your pre-submit passed on your PR, the Prow will also automatically merge your PR into the head of the branch. Also, this is my favorite part. You can also, under a Kubernetes issue or PR, you can drop a /meal or /woof. Our robot will find some dog or cat images or even animated images to add some fun while you're local development. Okay, that all sounds like magic. So how does it happen? What's happening under the hood? Imagine everything starts with a GitHub webhook. Like, for example, like the previous example, you drop a /meal and Prow will magically interact with your GitHub comment. So Prow runs on a Kubernetes cluster. So in this diagram, the blue box is actually a Kubernetes controller, and the yellow part are Kubernetes resources. So upon receive a GitHub webhook, so the hook component will dispatch the webhook to various of plugins. And at the time you open a PR, the hook will dispatch your event to a trigger plugin, and the trigger plugin will create a list of Prow jobs. The Prow job is basically a list of Kubernetes pod spec with some decorated fields that represent a pre-submit job under your PR. And so the Prow job is actually the core. Is a kind of Kubernetes CRD, and it's the core resource inside Prow. And all the other controllers are working around the Prow job CRD. For example, we also have a Tide, which is our merge automation tool. It will listen on the Prow job result and automatically merge your PR if all the pre-submit on your pull request has passed. Horologium is another controller that will schedule your job on a timely basis. For example, I want to build Kubernetes 1.12 release every 2 hours. So you can configure your job this way. Or I want to run a conformance test against my own cloud provider every 6 hours. And later on, when the Planck controller will track the status of the Prow job and actually create the actual Kubernetes pod on a different build cluster. Just FYI, the build cluster doesn't have to be a different cluster, but it's a kind of best practice because you can keep all the secret for your actual job in a separate cluster. You can also choose to schedule your pod in a different Kubernetes namespace. And after everything's done, we have Deck, which is our front end. Will show you a nice view of the running Prow jobs, and a Thinker controller, which will do some cleaning up. And this is I call it a better version of the Kubernetes Prow architecture. It's drawn by my colleague Ben the Elder. So you can imagine all of your workload is a actual container, and all the Gopher here are moving your containers around and try to kick off the task and report the status back to the sailing here, which is another tool called Test Grid, which can display the result of your other E2E runs. And we also have a tool called PR dashboard, which if you are an advanced contributor, you might see I submitted like 100 PRs. I cannot keep track of what's going on with all my PRs. So this dashboard actually shows you what criteria you are actually missing before your PR can be merged. For example, in this example, I can see my pull request 9747 is failing 2 of the pre-submit, like pull test infra basal and pull test infra verify GoVat. And it's also missing the LGTM label and has a do not merge work in progress label there. So once you address all the issues on your PR, you will see your PR is at a has a green label, which is okay to merge. You can find this dashboard at prow.case.io/PR. And Prow sounds awesome, so you might want to try it out yourself, not only for Kubernetes, but maybe also for you have your own project and want some kind of Git automation. So it's pretty easy. We have a starter.yaml manifest file in our Kubernetes test infra repo. You just need a working Kubernetes cluster. You dump the manifest into the cluster and configure your GitHub secret, and then you can start to add webhooks and also your workload. Okay, so beside Prow is already pretty overwhelming. It's basically the main part that handles the Kubernetes contributor workflow. But we also have a lot of other tools I want to introduce you today. So maybe you can find it useful in your own project. The first thing is called kubetest, which is also known as Kubernetes hack-e2e.go. It's a hacky script that triggers the end-to-end workflow for Kubernetes if you want to make sure your change is okay to if you want to make sure your change doesn't break Kubernetes. So you can actually before you send out the PR, you can run the test locally against any cloud provider, or even you have your own cloud provider and say you wrote your own Kubernetes service and you want to see if it works. And so you can simply write a deployer interface. You just need to handle a few interface functions. For example, how to bring up a Kubernetes cluster under your cloud environment, and how to tear down and how to dump out the logs. The second thing is test grid. Test grid is very useful for viewing a historical data of a job. For example, how this job behaves for the past 2 weeks. It's specifically useful for release team. For example, in the past 1.12 release, we want to see is the release blocking jobs are still healthy during the release. In this example, you can see the top 2 test cases are marked as red pretty consistently. So test grid will make it very easy to find out testing flakes and assign. It also has a SIG label in front of each test case, so it's pretty easy to find the owner of the test and basically nagging them to, hey, SIG foo, can you fix this issue for this release? And also Kubernetes. Test grid is good for viewing a historical data of a end-to-end job, but Kubernetes is good for viewing a single run of the job. It contains a lot of metadata and has some log highlighting similar to Travis. So you can see like what specifically is failing for your pre-submit and how you can fix it. Kind is currently in alpha. It's a new project we are working on. It's a I call it a new way to bring up a local Kubernetes cluster. If you want to test your change on a real Kubernetes cluster, it might take you a while. For example, on GCE, you need to take like 10 minutes to bring up a real Kubernetes cluster. But with Kind, you can boot a working Kubernetes cluster locally within like 30 seconds. And you can run multiple Kubernetes cluster locally on your workstation. So we have planned to migrate the default local testing to Kind. So imagine you can make a change to Kubernetes and run it inside Kind locally to make sure it's all working. Also forgot to mention, Kind is already passing the Kubernetes conformance test. So you actually is getting a conformed Kubernetes cluster. We also is going to give a talk about how to use Kind in Seattle next month, if anyone's around. We also have GoForage. GoForage is a coverage tool that basically showing you the testing coverage of any Go project. For example, in this case, it shows the coverage data in the Kubernetes repo between 1.11, 1.12, and master. We can see things are slightly better for each release. Boskus is a resource provision tool for Kubernetes. Imagine we are running thousands of end-to-end tests for Kubernetes every day. And how do we ensure we are not suffering from things like resource leak and quota issue? So Boskus is basically a resource pool with, let's say we have a pool of 200 clusters. When you start a end-to-end test, you will basically make a loan, like borrow a cluster from the pool. And once you're done with your test, you return the cluster back to the pool. And the pool itself has a self-cleaning ability. It will clean the cluster up and send to the next job. So user don't need to worry about like how to cleaning up my cluster after the test. Also, last one is Velodrome. Velodrome is a Grafana stack. It's basically our monitoring layer for the Kubernetes. Kubernetes branch house. It shows you like when is the last merge. If we haven't merged any PR into Kubernetes master for maybe 12 hours, that's probably means something bad is happening. Maybe some pre-submit is continuous failing and someone need to take a look. Let's give a pretty nice view especially for our testing for maintainers. For like whenever we need to react to a testing for outage. Hope these are all useful tools for you, and if you find it like any of those interest you or can probably fit into your need, you can approach us, and we can simply maybe just adopt them and making improvement of them. And you can also become a testing for maintainer for Kubernetes. Okay, I've talked so much. And so next I will welcome Jessie to talk about her project Knative and how Knative is making use of the Kubernetes testing for layer.
Right, thank you, Sen. Just a brief introduction. I'm Jessie Zhu, and my Chinese name is Zhu Sen, and I'm an engineering manager working for Google Cloud organization. So today I'm going to just, on top of Sen's introduction, I'm going to show like how Knative leverages SIG testing tools for our productivity and quality purposes. So just a quick poll from audience is how many of you have heard of Knative or even contribute to Knative projects? Yeah, I know Christy. Oh, cool. Great. So great to see that we already have audience know about Knative. So I'm just gonna give a very quick introduction to Knative. So basically, Knative is a open source collaboration and to define and to codify the best practices for running serverless workload on top of Kubernetes. And you see the slides kind of illustrates the high-level hierarchy for serverless products. And you can see Knative kind of sits in the middle, and it essentially provides a set of middleware components, which are very essential to for building the source-centric container-based applications that can run everywhere. And essentially, each of these building blocks corresponds to a separate GitHub repo under Knative project. So as of today, we have 11 repos, and we have, you see, like over 420 contributors, and they all come from different companies around the world. And they, together, they contribute and they generate a non-trivial volume of PRs and issues on a weekly basis. And those, like for PRs and issues, they cover like new feature requests, new design proposals, or some of them are kind of bug fixes. So with such kind of busy dynamics, it's really, really crucial for us to empower every single contributor to be as productive as possible, and meanwhile, to maintain the product quality at a very high level still. So you see that we want both, right? And actually, a little bit quick. So we want both, and so we kind of, actually, we are very lucky to actually find the SIG testing tooling that's already available to help us to achieve this goal. And I'm going to kind of briefly describe why SIG testing tools is kind of very useful for Knative projects. So first of all, they're very easy to adopt. There's like very clear guidance for us to follow, and it's running as a self-service model. So basically, you read the instructions, and then you follow those instructions, and you build your own instances. So for example, Knative, we have our own Prow instance, we have our own Kubernetes instance, and we have our own test grid instances. And they're highly reliable based on our pre-research, and right now is kind of our own experience of running those tools. They are very reliable, and like we rely heavily on those tools to ensure our quality and to ensure developer has a great experience and a great support. So like every time we have questions or every time we have run into issues, whenever we contact the testing working group, we get very responsive responses, and they are super responsible for these tools. And lastly is kind of from our contributor set of perspective, it's much learning curve for them, because most of those contributors, they come from Kubernetes ecosystem, and SIG testing tools can already working well for Kubernetes, and they're familiar with them. So it's much less learning curve, and they basically doesn't need to learn anything new. So that's kind of part of the reason that why we go with the SIG testing tooling. So next, I want to spend a few moments to kind of explain our guiding principles in terms of where and how we use those tools. So, so imagine, I think this is like a very typical grocery stores where I guess most of you no strangers to grocery stores. And imagine yourself standing in an aisle, and you face like a huge shelf, and they provide a great collection of goods. But oftentimes you're standing there and you find yourself at loss. Like, which product is the best product for me? How do I choose and pick between these like variety set of goods? And so I kind of have a question for audience is, normally what do you do? What do you do like when you go to the grocery store to buy something, and you see there's so many variety of brands there, and you want to buy something that's best for you, best for your family, what do you do? So this is like a good friend, like nutrition facts, right? That's what people realize on in modern world. And the nutrition facts, this is actually it's very well standardized these days, and actually also mandated in most of countries for packaged foods. And this essentially kind of differentiates one brand from another, and then you can rely on these numbers to pick and choose what's right for me. Like a lot of people looking for less sugar, a lot of people looking for high protein food, or they look for less sodium. So it provides a great guidance, right, for consumers to pick the right food. And so the same the concept has been kind of applied to a lot of other areas. For example, like for teacher. On the right, this is a mug that my son made for his teacher on the Teacher Appreciation Day. And that's kind of describe, hey, what a good teacher looks like for the students from their perspective. And likewise, we want to adopt the same concept for software. So you see, this is a table that we defined for Knative. This is the nutrition facts for Knative. And in terms of serving sites, we are defining it as a repo, which earlier I mentioned a repo kind of represents a building block, which means like a serverless component that then can be used to build top level products. And then within the context of this talk, we define the productivity metrics for each repo kind of as this list. So in particular, like time to triage, that's kind of stands for our desire to have an issue assigned to someone as quickly as possible. And time to merge, this is for a PR, that stands for we want a PR to be merged as soon as possible. And code coverage is meant to kind of gauge the quality of your code check-ins, right? So we want to make sure it doesn't break anything. And so does test flakiness. And for release, this is the kind of we want to release as regularly as possible, and then to kind of exercise our release pipeline at the regular basis, hence to ensure the reliability of our release pipeline. So these set of definitions and metrics kind of serves as a great guidance for us in terms of when we come to decide where do we want to spend our engineering efforts, and what are the goals that we want to achieve. So this essentially helps us to break down our engineering efforts into these three high-level areas. So one is kind of issue management. So that ties back to time to triage, time to assign, time to triage. And for PR, it kind of ties back to time to merge. And the release is this kind of release velocity. And I think earlier my table shows that we want to do at least a daily release. So next, I'm just going to talk about for each of those areas, like how do we use those tools that Sen has just mentioned. So for issue management, like we have Prow robots that does all the labeling. So that help us to triage our issues more efficiently, and also help us to filter and query the issues easily. And so this is kind of where we are, and we have future plans even to leverage the Prow robots to do automated triage, so that we can even bring down that time to triage, time to assign further. And for PR, so this gets a little bit more complicated, because in order for us to successfully merge a PR, it has to go through a list of checks and balances. So on the right, you see this is a screenshot taken from a Knative PR, and you see there's like how many 6 checks that we have to be passed before we can successfully merge a PR. So we do like legal agreement checks, and we run like build tests, we run integration tests, we run unit tests. All these tests has to be passing, and we also check for the code coverage numbers. And you can see for code coverage, like we also have a Prow job running for each PR, and then it does the incremental analysis to see, hey, what's the before and what's the after, and if the code coverage kind of goes below a certain defined threshold, we will actually block a PR. And on the right, it shows all the Knative Kubernetes instance. So this is what we use to kind of inform the contributors in terms of, hey, these are the list of tasks that are waiting for you to take action on. And this helps them to kind of unblock each other and help them to focus. And this is just example of like our nightly release, and on the right it's a screenshot of our Prow job. So this is the periodic job, and it runs every night to do the Knative release. And this is a screenshot of a test grid. So like I mentioned, Knative has its own test grid instance. And basically, we rely on this to surface all the key metrics that we defined for all our repos. So at the top, you'll see like these are just the repos that Knative has. So we have serving, we have build, we have eventing, and you'll see like these are all the repos. And for each repo, we show like code coverage, we show the latency, we show the release, and we show like the continuous test run results. And we also have like a summary page just to kind of give an overview of all these things. So like, yeah, so, and also like, as I mentioned, for test grid, one goodness about that is gives you a historical training view. So we rely on that as well to kind of track, see whether we are regressing or whether we are doing better or whether we are kind of maintaining our quality bars. So yeah, so that's, again, it's just a very nice application of SIG testing tools on Knative. So that kind of concludes my my deep dive on the Knative application. And if there's one thing that I would like you to take away with, I hope you will walk away from this presentation with a task in mind to kind of define what's the nutrition facts for my project. And then we would love to learn how SIG testing tools can help you to achieve whatever you define as your nutrition facts. And I'll hand it back to Sen.
Hello. Okay, thanks, Jessie. So last few slides is you might feel like, hey, I love all these, so I want to contribute. Yeah, sure, everyone is welcome to contribute to SIG testing. Just look for help wanted or good first issue label. It's the same process as Kubernetes. Actually, we encourage new Kubernetes contributor to contribute to test infra first. Thinks it's it's probably an easier learning curve for new contributors in test infra. Just send us PR and we will help you to get your first PR merged. And if you have questions, where to find us? We have SIG testing, we have Prow, we also have testing ops, 3 channels on Slack, which we are actively monitoring. We also have the Kubernetes SIG testing mailing list. And also, you can find file issues against Kubernetes test infra repo, or under your any Kubernetes PR, you can add test infra maintainers to signal us if you want us to look at something. Also, mention this again, we have a weekly SIG testing meeting at 1 p.m. PST. And if you want to learn more on general testing, Aaron from our team has a talk on adventures in conformance test tomorrow afternoon. And we also have a lot more testing related topics on KubeCon Seattle, and welcome to join us there. And last, let me also have a chance to thank all our existing Kubernetes testing infra contributors. And hopefully one day you will become one of them. And okay. Any questions?
How closely is Prow married to GitHub?
Yeah, so let me actually get back to the architecture diagram. So you can see there are a few arrows from GitHub to Prow. But you can also replace GitHub here with other Git providers. For example, Prow currently work with Gerrit. Gerrit is a Git provider that Chrome and Go language uses. So you can, let's say you invented your own Git provider, you can also write basically you need to write a controller that interacts with your Git provider, like say, how do I detect changes and how do I communicate to your Git provider? So basically not too tightly coupled. Let's talk offline. Yeah. Anyone else? Okay, thank you all. The nice closing image here.